Good morning, everyone. Yesterday's homework was from numbers 112 and 113. And you can say good morning to Mama too. Mama? Yeah, he's leaving. Okay. Say hi, Mama. No, he wants to be petted now. Can't do that, sorry. Okay. So number 112 was your homework. Here's the question. The average concentration of bromide ion in seawater is 65 milligrams of bromide ion per kilogram of seawater. What is the molarity of the bromide ion if the density of the seawater is 1.025 grams per milliliter? The trick here is to turn the mass into a volume and to turn, well, both masses have to be turned, one into volume, the other one into moles, because the units of molarity are moles per liter. So 65 milligrams of bromide ions per kilogram seawater. We know that molarity is the number of moles divided by the volume. We're told there's 65 milligrams times 1 gram per 1,000 milligrams. And bromine has a molar mass of 79.904, or bromide rather. And bromide is monatomic. Okay, so you don't have to worry about it being diatomic because it's Br minus, it's not Br2. Then for the denominator, the volume is 1 kilogram times 1,000 grams per kilogram. Allows you to cancel kilograms. And since density equals mass over volume, if you have a mass, then the volume is equal to mass over density. Times so it's 1 liter per 1,000 milliliters, and it's all over 1 over 1.025 grams per milliliter, and that all equals to 8.134, 761, 71 times 10 to the negative 4 moles of bromide for every 0.975609756 liters. So the molarity turns out to be 8.33813 0.075 times 10 to the minus 4 molar. If you multiply by 1,000 millimolar per 1 molar, you can use a more appropriate unit. It comes out to 0.83 millimolar. I give a little more extensive explanation of how I got the denominator. If you look at the upload, I've been noticing that the uploads lately are taking a whole day to go on. So I'm thinking maybe starting from tomorrow, I'm going to start just pre-recording the videos and posting them, because it's taking, I'm having a very low viewership. There's only 2 people watching right now, and they only load something like 18 hours later. So I think YouTube is putting my my live transmissions as a very low priority. I find also when I upload just the regular video, it does it within 5 minutes, so I can get the stuff to you much more quickly. So I think this whole thing of going live is not actually conducive to getting the material to you any more quickly. So I think starting from tomorrow, I'm just going to pre-record and upload half-hour videos explaining all the stuff you need to know, and you'll get it faster that way. But I would like the same idea of you writing your name after you've watched it to prove that you've looked at the material. Okay, so let's look at 113 next. It says the mass percentage of chloride ion in a 25 milliliter sample of seawater was determined by titrating the sample with silver nitrate, precipitating silver chloride. It took 42.58 milliliters of 0.2997 molar silver nitrate solution to reach the equivalence point in the titration. What is the mass percentage of chloride ions in seawater if its density is 1.025? So the way we set this up, so we've got chloride ions being titrated by silver nitrate. We know that silver combines with chlorine, chloride ions to form the insoluble precipitate silver chloride. So they give us a certain molarity of silver nitrate, and it takes 42.58 milliliters of that solution to titrate the 25 milliliters of chloride ions. So let's find out how many moles of silver nitrate that equals to. I'm almost contemplating jumping on the counter. Go ahead, do it. What do you mean it's too high? There you go. So there's the moles of silver nitrate. And we're going to multiply by the molar mass of silver nitrate. Sorry, no, we're going to multiply by the molar mass of chloride to find how many grams of chloride are in that, because the number of moles of silver nitrate has to equal the moles of chloride. So we have the moles of silver nitrate, and we could say and chloride because one's titrating the other. So now we're multiplying by the molar mass of the chloride, and it gives us that we've got 0.45 to 419 grams of chloride in our 25 milliliter solution. So the molarity is going to be, again, N over V. So 1.276, etc., times 10 to the minus 2 moles of chloride divided by the volume of the solution, which is 25 1,000ths of a liter. Gives you a molarity of 0.510. 44904. But actually, that's not what they were asking. They were asking for the mass percent. Well, let's find out the mass of the water. Since density equals mass over volume, and therefore density times volume equals mass, we've got a density of 1.025 grams per milliliter for the water and 25 milliliters. So that works out to a mass of 25.625 grams of water. So we've got the grams of chloride, grams of water, so the mass percent is going to be 0.452, etc., grams of chloride over 25.625 grams of water. Multiply that by 100, and we get a percentage. Got no room, so I'm going to go straight to the answer with the right number of sig figs. It's 4 sig figs. It's 1.766% chloride by mass. That's your final answer. Okay, now you want to go back in the room. Okay, here you go. That's number 113 done. I'll do 114 with you, and then we can start reviewing chapter 4. I have to give you some kind of mark by the 23rd. So I still have to think about how I'm going to approach this. I'm thinking of just going through the videos to see who was watching the videos, and maybe this week I'll ask you to do some. I'll ask you to do something. I don't know how I could mark it fairly because there's no way of monitoring that you're actually doing it based on the knowledge you have in your head. Maybe if I ask you to do some problems that I make up, I could do that. I could ask you to do the problems. I'll think about it tonight, and I'll let you know tomorrow. Okay, let's do one more, and then we'll wrap it up for today. It's 114, number 114. It says, the arsenic in a 1.22 gram sample. Actually, you know what? I was looking at some stuff yesterday that I thought that would be better to do. And that is how to explain precipitation reactions. You know that when you mix salts in water, some of them dissolve and some of them don't. Sometimes you can mix two different salts in the water, so you can have two clear solutions, and as soon as you mix them, all of a sudden you get a reaction, you get a precipitate forming, and it goes to the bottom of the beaker. How do we determine whether or not something is going to react or not? The trick to doing that is to look at a solubility table. Now, you can look up the one in the book, or you can look up a solubility table. I'm sure you can find some solubility tables on the internet. You can also go in my playlists, and I'm pretty sure I have a playlist called Solubility Rules. And I recommend you watch that video because it'll help you understand how that works. But typical problem that you would get along those lines is number 27 in the text. So I'll go to that one, to that example for you. So it says, you know that an unlabeled bottle contains a solution of one of the following: silver nitrate, calcium chloride, or aluminum sulfate. A friend suggests that you test a portion of the solution with barium nitrate and then with sodium chloride solution. Explain how these two tests together would be sufficient to determine which salt is present in the solution. So what you would do in this situation is set up a table, like a little matrix, to show you what the possible mixes are, because you have three possible anions floating in the solution, and two testing solutions. Right. Okay, so we'll do that. So this is number 27. I set up a little matrix. What's being tested is silver nitrate, calcium chloride, and aluminum sulfate. Then the testing solutions that are being used are barium nitrate and sodium chloride. So now all you have to do is predict what's going to happen if you mix each one of these possible combinations. So if you mix silver nitrate with barium nitrate, the counter ions are both the same, so you get no reaction, nothing happens. This is the same counter ion. They'll both be soluble. But if you mix silver nitrate with sodium chloride, then the sodium is going to combine with nitrate. That's still soluble, but silver and chloride, you're going to get a silver chloride precipitate, because silver chloride is very insoluble in water, and you can look it up on any solubility table. Chlorides of silver are not soluble, so it will form a precipitate. Then, if you combine calcium chloride with barium nitrate, you're going to get barium chloride as a precipitate, because chlorides of barium are not soluble. Nitrates, all nitrates are soluble. So anytime you see nitrate as the counter ion, you know the thing is going to be soluble. But chlorides and barium, no, you're going to get precipitation in water. Calcium chloride with sodium chloride, same counter ion, no reaction. Aluminum sulfate with barium nitrate, you're going to get aluminum nitrate, which would be soluble, and barium sulfate, which is not soluble. That one's going to produce a precipitate. And then if you combine aluminum sulfate with sodium chloride, you're going to get aluminum chloride, which is soluble, and sodium sulfate, which is also soluble. So in fact, you get no reaction. They're both soluble, so they're more attracted to the water molecules than they are to each other. So as the table suggests, two precipitates form with barium nitrate, and sodium chloride reacts with the one chemical that does not react with the silver nitrate. So with these two testing reagents, you can get a reaction out of all three. So this one will get a reaction out of these two, and this one will get a reaction out of this. And that's how you can determine, that's how you can precipitate things also selectively. If you know which reagent to choose, you can selectively extract certain ions out of solution. You could try 26 for homework, because it has a similar setup. You can make a little table, and and predict which one will produce precipitates. But of course, to do that, you need to have a solubility table. I know I have a solubility table in one of the playlists, so it's on the board as a note. You can copy that note from solubility rules. It's a playlist called Solubility Rules, and then from those rules, you can predict whether something is going to be soluble or not, whether it's going to produce a precipitate or not. You should be familiar with how to write the molecular, the ionic, and the net ionic equations. Just to give you a little refresher, I'll give you a sample of that, and then we'll wrap it up for the day. I hope you're all don't get too comfortable. I predict this pandemic is going to be over before the end of April. The numbers are already dropping from what I've seen. Trump has defunded the World Health Organization because they made mistakes in the predictions. He also called them China-centric, and there's in my opinion there's evidence of bad will in some of the players in those organizations, and I think that they've been inflating the numbers to drive some other agenda. At any rate, I hope we'll be back to school by May. I'm hoping that they won't drive the whole country into bankruptcy by keeping everybody at home, because that's what's going to happen if people don't work. It's already happening. I'm seeing that farmers are complaining that they're having to throw away crops because there's nobody working in the processing plants. So their food's being wasted. People are out of work. Their mortgage is still coming due. The banks aren't being very helpful because they're saying they can have mortgage deferrals, but then they're charging extra interest. So there's all sorts of skullduggery going on. It's unbelievable. We need to get back to work. And your education is not done. This has not done your education a favor. Based on the numbers I'm seeing on the daily attendance, I know there's some people watching after, but this is not doing you any good. So we need to get back. And hopefully once the numbers drop low enough that this so-called pandemic is blown over, we'll